Hello, my amazing students. This is Mrs. A, and this is the night before your test. Actually, it is the morning of your test because it is currently 12:13. But I wanted to show you a few of the compound inequalities that I had promised you. But like most people in Niceville, I have been preparing for a hurricane that may or may not come our way. So here are the couple of problems that I wanted to do for you just to remind you about the and the or. Okay, remember when we have a problem that is a compound inequality and there's an and in between, that means we're going to have all the points that make both true. Because remember, and means the same thing as intersection. And intersection is what the two groups have in common. Okay, so when you are thinking about and, you're thinking about what the two groups have in common. So the first thing we're going to do is graph x is less than -3, just like we did on the first part of this video that I had already posted because this was getting delayed. So x is less than -3. First, we're going to plot the line x is equal to -3. Remember, x cuts the x. So I'm going to cut the x-axis with a line at -3. So this is the line x equals -3. But because it's an inequality without an equal sign, I'm going to make it a dashed line. Okay? And then x is less than means all these points over here. But you can always use 0, 0, even with no y in there, because if we were using a test point 0, 0, we would simply plug 0 in there for the x, even though there's no y. So we'd get 0 is less than -3, which we know is not true. Therefore, we shade on the other side of the line. Okay, so now we're going to grab a different color. Remember, I told you having colors is a good thing for this exercise. So we're going to plot this line in green. Okay, so we've got 5y minus 2x, and we're going to pretend it says equals -15. Okay, so the first thing I'm going to do is I'm going to do this two ways. I'm going to use the x and y intercepts, and then I'm going to use the slope from our -a over b. We have a problem though. It starts with a y. It's not in standard form. But we do know the c is over here, the a is here, the b is here. We can just switch it around. It's very flexible. So here we go. If I'm going to find the x-intercept, I let y be 0. So I'm going to put my finger over the y, and I end up with -2x is equal, because I'm pretending that's an equal to -15. Since I have a negative on both sides, they're going to cancel each other out, and I'm going to have 2x is 15, or x is 15 halves, which is 7.5. Okay, so x is 1, 2, 3, 4, 5, 6, 7.5. Okay, way over there. And then I'm going to let the x equal 0, which means I'm going to cover that one. And I'm going to get 5y is -15, or y is -3. Okay, so y is 1, 2, 3, -3. Bless you. So now I've got a greater than or equal to, which means my line will be solid. So I'm going to take my x-intercept and my y-intercept and draw my line through both of them. Okay, and we're going to shade in just a minute. But we're going to go ahead and do the other method, which is to just show you how easy it is to do this. Remember, this is my x, so this is my a term. This is my y, so this is my b term, and there's my c. I'm pretending this is an equal. So my slope is -a over b. So it's going to be negative a -2, which is a +2, over 5. My slope is positive 2 over 5. So let's write it up here. M is 2 over 5. Okay? And my y-intercept is c over b. My c is negative 15 and my b is 5. So my y-intercept is negative 3. Where did our y-intercept end up being? Negative 3. Okay? So just to check our line, we're going to start here at our y-intercept and go up 2 over 5. Up to 1, 2, 3, 4, 5. Bink, right on the line. Okay, so it does look like our line is correct. Now to figure out which way I'm going to shade, I'm going to plug in my point 0, 0. Again, is not on my line. Therefore, I can use it as my test point. I'm going to plug 0, 0 in here and here, and I wind up with getting 0 is greater than negative 15, and 0 is greater than negative 15. So I will shade towards my 0, 0. Okay, so I have a shading over here for my first inequality and a shading here for my second inequality. And of course, this is going on up for, there you go. But remember that you should leave all of that work there, but then take your pencil and heavily shade the part that is indeed the solution. Because it has an and, that means we're only going to shade the part that makes both true. In other words, the part that is both green and black, okay, which means this part down here that's only black will not be shaded, and this part over here that is only green will not be shaded. And let me see if I can do this here. We're going to shade the part that is green and black. And that is the solution to the inequality, the heavily shaded portion here. So when you take your test for me tomorrow, you do not erase your work and only leave the red part here. You show me the black part, okay, the first inequality, lightly. You show me the other inequality lightly, and then you thoroughly shade the part that is going to be the solution that's both. Now, before we move on to another problem, what would this look like if we were doing an or instead of an and? Remember, an or means either or. Anything that makes either or correct. So basically, that's the one I say throw it all in a sack. Okay, so basically, if this was an or, we would have this heavily shaded, we would have this heavily shaded, we would also have this heavily shaded, because all of those three sections would be an or solution. Okay, so I'm going to do another problem for you shortly. Okay, this is the last one that we're going to do on this little segment, and it is an or problem. And or means we're just going to take everything that's shaded one time as part of our solution. So here we have our first inequality, y is greater than or equal to 3/2 x. Now notice, we do have an x on this one. This is a slope-intercept form of the line with no y-intercept, which means that the y-intercept is 0. So in graphing this one, we're going to start at 0, 0, 0, and we're going to go up 3 over 2, up 3 over 2. So 1, 2, 3 over 2, 1, 2, 3 over 2, or down 3, back 2. They both work. So then we're going to neatly draw a line, and that line is going to be solid because our inequality has an equal sign. So now we have to figure out which way to shade, but our inequality goes straight across 0, 0. Our line goes straight across 0, 0. So we have to pick another point, and I'm going to pick 2. The reason I'm going to pick 2 is because this is 3/2 and they have a 2 on the bottom. So if I pick 2 for x, So we're going to plug in 2, 0 as our test point, okay? And 2, 0 is right there. So there's my test point. And if I plug in a 2 here, then the 2's cancel, and I'm left with 3 on the right-hand side, and 0 is greater than 3. Oh, that's not so. So we will shade away from the test point, which is going to be on this side of the line. Okay, now a lot of you, when you have it in slope-intercept form, it's very easy to say y is greater than the line. So y is going to be above the line. And if you look at that, that is above the line. But a test point always works also. Okay, so I just obliterated my equation, but it is 3x plus y is less than 3. Okay, I'll copy it again. And let's do this one by first using our x and y intercepts. If I let x be 0, cover that up, then y is 3. Remember, when I'm doing this, I'm plotting my line, I'm checking, I'm letting this be equal. So I let x be 0, y equals 3. So my y-intercept is 3. There it is, okay? And when I let y be 0, my x is 1, okay? Because I'm pretending that's an equal sign. So x is 1. Now I'm going to go ahead and erase this. This was a test point before. I'm going to erase it. We don't need it there anymore. So y is 1. X is 1 is my x-intercept. So now I'm going to switch, because I'm doing everything in black and I want it to have some sort of a difference in color. Okay, so I'm coming from this point here down to this point. Let me draw a nice little green line. All right, so now I just did something wrong, because this one has a less than instead of a less than equal to. So that means that my green line should be dashed. So I'm just going to make it kind of dashed there. Okay, not solid. And then I have to figure out where to shade it. 0, 0 is off the line now, so I can use 0, 0 again. And if I plug in a 0 and a 0, I get 0 is less than 3, which is correct. So I'm going to shade towards 0, 0. And now you can see that I have my both inequalities graphed. Now, this is an OR inequality, and OR means that everything that is shaded one time is the solution. Okay, so I'm going to take my red marker and I'm going to shade everything that is shaded once, because it doesn't have to be shaded twice to be the solution. If this were an and, then that would be intersection, which would mean that we would only shade this part that is shaded twice with both the black and the green. But this one is an OR, so we will take our marker and we will indicate that everything that got shaded once is the solution. And that is how easy inequalities are. So I am done with teaching you those lessons, and hopefully you found the little videos helpful, and if not helpful, at least entertaining. So I will see you tomorrow for a test. I hope that you will study very hard. And this is Mrs. A, and may God bless your day, or your night as it is.